Hi, I'm Jeremy Avellino with Bright Common Architecture and Design, and welcome to Play Arts. This is a space that opened up yesterday. It is a play-based arts and enrichment center for kids and their parents or caregivers. This area of the city, we're in sort of Fishtown, Kensington area. Back then, indoor plumbing was still a luxury. And so the city set up a whole system of bathhouses for people basically to bathe. And so it eventually morphed into more of a public pool. Very early on, we identified some goals for the project, which involved energy efficiency, particularly related to operational costs over time. The second big goal was a high level of indoor air quality and thermal comfort. This is a commercial project which has, anywhere from 3 people in the space on the low end to 100 people in the space on the high end. And it's about 4,000 square feet between all the different spaces. We used Passive House principles to guide every step of the way, really. This is the wonderful adventure-based play space. And there's all kinds of amazing stuff that happens in here all day, but it's not the kind of space for helicopter parents. And I think that that's really interesting because kids can just kind of climb up into the row houses that Steve made, or underneath the little hobbit holes, or any number of things. There's going to be a water tower over there that's almost done. Up here is the, I call it the Tired Parents Cafe. That's where we hang out and drink amazing Reanimator coffee and just sit down and watch your kids go nuts down here. It's really fun. This bar joist roof was installed in '69 because the original roof had collapsed. It had this beautiful set of monitor lights that let in a copious amount of lighting. Underneath this maple floor, it was the actual pool, which is now sort of this strange crawl space in the basement. And we played around with some ideas of actually sinking like kidney pool-shaped ball pits, but that sort of proved to be very expensive. So we left this beautiful floor, and there's sort of a concrete pool down there just waiting to be inhabited. So we're in the reading nook in the main play space. So the way we approached the walls on this project, where there was a building on the other side, we only did air sealing, and that involved repointing in multiple coats of vapor open paint. And where there wasn't a building on the other side, we did this foam-free approach where we made sure that there wasn't any oil paints or anything else that would trap moisture on the other side, and then did some mold remediation on the inside from a previous renovation, and did a lime plaster parge coat, 5.5 inches of dense packed cellulose, a layer of Intello Plus, which is our vapor variable air barrier and smart vapor retarder, a service cavity, and drywall. One of the most challenging things about this project was keeping the sort of Passive House red line, the continuous air barrier, keeping that intact, right? And some things look good on paper and don't always work out so well in the field. So the lesson learned on this one was, where our Intello layer goes up, it magically tapes to this sort of old and deteriorating corrugated metal deck with the hopes that that layer is airtight and that it's also attached to the polyiso, which was taped. And I think that that was a hopeful connection, and I think it's doing good enough. And I think that we did all that we could there, short of we didn't want to do interior insulation and have to cover up these bar joists, so that was sort of a compromise on the project. And so going down the Intello layer, Steve was careful to cut the maple flooring back to the point where he was furring out the wall, and he turned the Intello down and taped it to the old concrete. And so we blower door tested it at least during the renovation to make sure it was airtight, and we're planning on doing a final one after that. One of the biggest challenges of this project was, in a deep energy retrofit that's a commercial use, is pretty radically different from one in a residential use, whether it's a single family or multifamily. And that has to do with the amount of people in here, and the kinds of things they're doing. And so, once you super insulate and air seal a building, really the mechanical systems are less concerned with the building envelope, the loads there almost just disappear. It's what's happening inside of the building. We went back to the mechanical engineer, talked about our super insulation and air sealing, and they were sort of like, that kind of doesn't matter with this. It's internally load dominated, and so we have to take care of cooling. And so their solution was literally to pull in the middle of July, the hottest, most humid air Philly has to offer, and dump it through a 50% ERV, which was in line with the ductwork, into the space. So on top of having kids who are giving off heat and humidity, they're dumping barely cooled air into it. It just absolutely made no sense to me, and I knew that I was a little bit naive about this, and I think that was in my favor. And the mechanical engineer was very amenable to coming up with another solution too. They were wonderful to work with, actually. We wanted to see if we could use ductless mini splits and even residential grade mini splits to provide the heating and cooling. And we wanted to see if we could stage the heating and cooling so that, say only one would need to be on in one of the spaces if there's only 2 people in the building. And we could have, up to 11 on if there's 100 people here. And so what we decided in the end for heating and cooling was to do just that. Each of the 11 units is tied to its own compressor, which seems excessive and was a little bit more expensive in terms of the front end cost. But now we have an infinitely stageable system where we can service 1 person or 100 and not waste energy by having 12 tons running throughout the night just to actually heat or cool a space when no one is here. So the systems can actually shut down at night as well. Instead of providing one giant roof-mounted ERV, we went with 4 essentially residential grade ERVs with the same intent, and they would be intertied with CO2 monitoring. So if there's a small amount of people here, there's probably only going to be 1 on, because the air is not very stale and just doesn't need to be refreshed that much. If there's 100 people in here, all 4 are going to kick on, and they're ducted separately, and they're on separate monitors. So there's a little bit of upfront expense with that system, but we expect that to pay for itself in 2 to 5 years. Even so, compared to the cost of what it would have cost to put in 12 tons of gas-fired rooftop units, basically, and all the extra steel dunnage, the cost for this system was at least comparable, if not less. So we're really pleased with the results, and it's a really wonderful project to be involved with. We're really excited about it.